Okay, continue with the 6.6, the trapezoid and midpoint drills. And we know that most of the integral and most of the integral applications within the outside of the mathematics and involve the definite integral, which is the I equals to integral from a to the b, k f of x del x, and please remember the fundamental theorem of calculus, and we can evaluate such definite integrals by the first finding an antiderivative of f, you know that, and this was we have spent considerable time on developing techniques of integration, and there are, however, two obstacles that can prevent our calculating the I this way. And let me give you some information about the numerical integration and of course the indeed any Riemann sum. Okay, and what I mean, and first let's talk about the trapezoid rule, and let me write the finding. We know that for this finding an antiderivative of f in terms of familiar functions may not be possible or may be very difficult and we may not be given a formula for f of x as a function of x Okay, and we assume that the f of x is continuous on a comma b close interval, and let's a comma b subdivided into n subintervals, and which is length h equals to b minus a, and divided by n, and using n plus 1 points, and that means x0 point equals to a, and the x1 equals to a plus h, right? and the x2 equals to a plus 2h, okay, and it goes on like that, and the x sub n equals to a plus I'm sorry, n times h, okay, and it goes on like that again, and the x n equals to b, okay, and of course y0 would be f of x0, and the y1 equals to f of x1, okay, and it goes like that, and the yn equals to f of xn, okay, and I'm sorry, this point was not here, it's not true maybe, or x n equals to, okay, and the b, and for that y of n equals to f of xn, okay, and after that, okay, let's sketch a function curve on the coordinate system to understand this trapezoid. Okay. And it's like that, okay, and let's continue with these green lines, okay, and equal intervals, okay, by the way, and it goes like that. Okay, and as you see, all of these points here, okay, and these points are, for example, this is A, which is x0, and this is x1, x2, x3. It goes like that, and this point is x n minus 1, this point is xn, okay, and all of this intervals equals to h, okay, as you see, h and h, okay, and when you connect these points by, and let me write this one is y0, y1, y3, y2, y3, and the yn, and the yn minus 1, okay. Let's connect all of these points, okay, by lines, okay, like that. okay, and the okay, sorry, and then as you see we have just connected all of the points by lines, and that means the trapezoid rule approximates, okay, any definite integral which is the f of x, okay, integral from a to the b, okay, by using these straight line segments, okay, between the xj minus 1 and xj points, okay, and let me give you this points exactly, okay, and for example let's zoom in, for example this line, okay, and these are as you see, my friends, to calculating this geometric area is easy than the other curve area, okay, and so that means this point, for example x0, x1 of course, and this is y0, y1, okay, and that means this point is h and this point is h, okay, and for this point we know that the y0 minus y1, okay, and when you calculate this green shaded area, it's equal to, okay, h times, right, and the y0 plus y1 over 2 square units, okay, and so this can be seen geometrically by considering the trapezoid as the non-overlapping union of rectangle and a triangle, okay, and so we can say from this approximation, okay, and the integral, definite integral, which starts from x0 to the x and x1, okay, and the f of x, okay, del x approximately equal h times y0 plus y1 over 2, and this is only about the x0 and x1 interval, and so you can generalize it to the any interval which is the xj minus 1 to the xj f of x del x, okay, and the approximately equal h times, okay, yj minus 1 plus yj over 2, right, and the 1 is less than or equal to j is less than or equal to n, right, and of course it follows something, and the original integral, of course, and the original integral, which is the I, can be approximated by some of these trapezoid areas, okay, these are the some trapezoid areas, okay, and when you generalize it again, okay, and you will say integral from a to the b, okay, and the f of x del x, okay, it equals to h times y0 plus y1 over 2 plus y1 plus y2 over 2 plus y2 plus y3 over 2 plus it goes on like that, and the last term is yn minus 1 plus yn over 2. Okay, and as you see, when you add these green parts, okay, to each other, okay, you will obtain the only y1, y2, y3 plus plus and the yn minus 1. Okay, so let's simplify the equation again, and it will be equal to h times, okay, 1 over 2 y0 plus y1 plus y2 plus it goes like that, and the yn minus 1 plus, okay, 1 over 2 yn. Okay, and let me write the definition of the trapezoid rule. And the d and subinterval trapezoid rule approximation to definite integral f of x del x, okay, denotes the t sub n and is given by t sub n equals to h times 1 over 2 y0 plus y1 plus yn minus 1 plus 1 over 2 yn. Okay, this is the trapezoid rule. Okay, and then let's talk about the some of the values, okay, and which is about the, of course, from example. And the I equals to integral from 1 to the 2, okay, 1 over x del x. We know that this integral equals to ln x, so that means ln 2 minus ln 1, and which is equal to, of course, ln 2, because ln 1 equals to 0. So when you calculate this value, it will be equal to 0 point, okay, 693147118. It continues, and of course this is an irrational number. Okay, and let's now calculate and these values by the trapezoid rule approximations and the T4, T8 and T16 values, okay, and calculate the trapezoid rule approximation T4, T8 and T16 for I equals to integral, okay, from 1 to the 2, okay, 1 over x del x, okay. The solution for n equals to 4, okay, and it will be h equals to b minus a, b equals 2 and the e equals 1, so 2 minus 1 over, okay, n, which is 4, so h equals to 1 over 4, and the for n equals to 8, so h equals to 1 over 8, and the for n equals to 16, and the h will be 1 over 16. Okay, and then let's calculate the t sub 4, okay, and the t sub 4 equals to, firstly we know it's from the formula, and the h times, that means 1 over 4 times, okay, parenthesis 1 over, okay, q times y0, okay, y0 means, okay, y0 means, that means the f of 1, so f of 1 equals to 1, plus y1, that means, okay, 1 plus 1 over 4, okay, so it would be, okay, 5 over 4, and the 1 over 5 over 4, it will be equal to 4 over 5, okay, and the plus 2 over 3 plus 4 over 7 plus 1 over 2 times, okay, and the last one, which is b, okay, and the 1 over, okay, 2, it equals to 1 over 2, okay. So when you add all of these rational numbers to each other, and when you take these by the calculator, and you will find the 0.69, okay, 702,381. It goes like that, and look at this value, 6970,6931, okay. Yes, it's not exactly, but it's very similar, okay. And let's calculate the T8. T8 equals to h times, that means 1 over 8 times 1 over 2 times, okay, 1, and after that x1 equals to 1 plus, my friends, okay, 1 plus h, okay, and it will be 1 over 8, okay, 1 plus 1 over 8 equals to 9 over 8, so we know that the function is 1 over x, so 1 over, okay, 9 over 8, it will be equal to 8 over 9, okay. By doing this approximation, you will find all of the numbers, okay, like that, 4 over 5, 8 over 11, plus 2 over 3, plus 8 over 13, plus, and the 4 over 7, plus, and the 8 over 15, plus 1 over 2 times 1 over 2. As you see, 1, 2, 3, 4, 5 points, and here will be 9 points, okay, and it's equal to 0 point, okay, 6941218 okay. This is more similar than T4, okay, when you look the real value of the LN2, okay, and when you take the, I'm sorry, T16, okay, 1 over 16 times, okay, blah 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 blah, okay, and you will find the T16 equals to, okay, 0.69, okay, 3391, okay. My friends, that means when you take more subintervals, okay, you will approach to the real value, okay. So and now I want to talk about the midpoint rule, okay, and let's continue with it. And the somewhat simpler approximation to the integral from a to the b f of x del x, okay, and based on the same partition, which is a comma b closed interval, and into the n equal subintervals, involves forming the Riemann sum of the areas of rectangles, okay, and whose heights are taken at the midpoints of the n subintervals, okay. That means now, for example, now you have again a curve, okay, and these are subintervals, of course. And now we will take these midpoints of the rectangles, okay, calculating the real value of the definite integral, okay, and these points are M1, M2, middle point, that means M3, it's the Mn, okay, and the y equals to f of x, and of course x, it starts here, and the x0, and this is the xn, okay, and let me write the definition of this midpoint, okay. If, okay, and these are h, okay, and if h equals to, okay, b minus a over n, and let mj equals to a plus, okay, j minus 1 over 2 h for 1 is less than or equal to j is less than or equal to n, okay. The midpoint rule approximation to integral from a to the b f of x del x denoted Mn is given by, okay, Mn equals to h times f of m1 plus, okay, f of m2 plus f of mn. That means generalized form h times summation j starts from 1 to the n, okay, and the f of mj, okay. This is the trapezoid rule. I'm sorry, this is the midpoint rule. And let's write an example. Find the midpoint rule approximation, okay, and the M4 and M8, okay, for the integral equals to from 1 to the 2 1 over x del x, same integral, okay, and to find the m sub 4, okay, and the interval 1 comma 2 close interval is divided for sub intervals or equal sub intervals, okay. That means 1 comma 5 over 4, okay, and the other one is 5 over 4 comma 3 over 2, and the other one is 3 over 2 comma 7 over 4, and the last one is 7 over 4 comma, okay, 2. These are two equal subintervals, and the midpoints of these intervals, okay, and they will be and you choose the midpoints of them. That means 5 over 4 minus, okay, and the 1 over 2, that means, and it will be 1 over 4, okay, and this interval midpoints for this 9 over 8, for this 11 over 8, and for this 13 over 8, okay. How we have found these values? Okay, it's very easy, okay. 5 over 4 minus 1 is equal to 1 over 4, okay. When you add the left value, or when you subtract this from the right value, okay, and it will be, okay, I'm sorry, 1 over 4 over 2 is equal to 1 over 8, okay, and when you add the left value will be 9 over 8, okay. That means midpoint, okay, and the M4 equals to h times, which is 1 over 4 times, okay, and the f of midpoints, which is 9 over 8, and it will be 8 over 9 plus, okay, 8 over 11 plus 8 over 13 plus 8 over, okay, 15, and you will find the 0.69121989 goes like that. And when you calculate the m sub 8, okay, you will find the 1 over 8 times, okay, 16 over 70 plus 16 over 19 plus 16 over 21 plus it goes like that, and the after 16 over, okay, 29 plus 16 over 31, so it equals to 0. Okay, 6926605. Okay, and you can calculate the errors, okay, in this approximation. For example, a real integral value, okay, minus to do m4, it equals to, that means 0.693, okay, 147, okay, for example, minus, okay, 0.69121 9, it equals to 0.00192, okay, and they calculate this error. This is error, okay, error for m sub 4 midpoints rule and the m sub 8 midpoints rule, okay, and again 0.6 minus 6, 0.692660, it equals to 0.0004. Okay, as you see, this error is smaller than the above error. Okay, so when you take lots of bigger midpoint, okay, for any definite integral, you will approach to the real integration value, okay, if you have enough time, of course.